Algebra 1, Lesson 85. We are looking at the Pythagorean theorem and being able to solve problems using that. Now, remember that the Pythagorean theorem states that if we have a right triangle, okay, and let's say we have side lengths A, B, and C, we can say that A squared plus B squared equals C squared, meaning the area that would come off of this side A plus the area that would come off this side B would equal the area of this side C. That is the Pythagorean theorem. And if we are missing any one of those sides, we can find the other one by using the Pythagorean theorem. The other thing we can do is if we have all three sides, we can prove that this is a right triangle by making sure it works with the Pythagorean theorem. Let's start though by just finding some missing sides. So like this one, if we were to plug this into the Pythagorean theorem, we would say I have A squared, okay, so I have 6 squared. B squared, we have 8 squared equals C squared, which means I get 36 plus 64 equals C squared, which means that C squared is equal to 100, and I can take the square root of each side to see that C is 10. Now the other way to do this one is know some of your Pythagorean triples. And in this case, it follows my Pythagorean triple of 3, 4, 5. Okay? And any multiple of this will be a Pythagorean triple, which means in this case I can have 6, 8, 10, a multiple of 2. Or I could have a multiple of 3 of 9, 12, and 15, and so on and so forth. So we can use these Pythagorean triples to remind ourselves that that is a common right triangle, and I can find the missing side by using a multiple of this. All right, let's try this one though. In this case, we are missing a leg, and we have the hypotenuse. So I actually have 4 squared plus t squared is equal to 7 squared. All right, so we have 16 plus t squared equals 49. So I subtract 16 from each side and get t squared is equal to 33. So the square root, okay, square root of 33 is the exact side length of t. But if I want to estimate this to the nearest tenth, I would say, well, which number is it closest to? Square root of 33 is definitely between the square root of 25 and the square root of 36, giving us perfect numbers of 5 and 6. And it's closer to 6, which means maybe I'm looking for something like 5.7 or 5.8, maybe even closest 5.9. And all we need to do is multiply those out, 5.7 times 5.7, see how close it gets to 33. When we do look at the square root of 33, we see that it ends up being 5.744 and so on and so forth. So we'd say the nearest tenth is 5.7. Okay, that is a good estimate of the square root of 33, but the exact answer is actually the square root of 33. All right, let's try to find k here. And in this case, we're missing a leg, so I'm going to do 5 squared plus k squared equals the square root of 61 squared. I multiply it out, I get 25. Plus k squared equals, well, square rooting and squaring ends up canceling each other out, and we just get 61. I subtract 25 and get k squared is equal to 36. So taking the square root, I see that k is equal to 6. Okay, and another one here. If I take 32 squared plus k squared equals 40 squared, well, 32 squared gives me 1,024 plus k squared is equal to 1,600. That's what 40 squared is. So I subtract 1,024 from each side, and I get 576 equals k squared. Take the square root of each side, and we see that k, and now the square root of 576 is actually a perfect number. It gives us 24. So we see that the leg k here is 24 units. All right, so this is how we're using the Pythagorean theorem to find a missing side. Now, once again, Pythagorean triples can be helpful. So these are truly 3 non-zero whole numbers which represent the lengths of a right triangle. So we have things like 3, 4, 5, Other common ones are 5, 12, 13, and there's a few more that we use. But these are the most common. But there are other Pythagorean triples, and what we need to do is figure out, do these whole numbers plugged into the Pythagorean theorem, will they give us a right triangle? And all we need to do to try it out is plug it in and say 9 squared plus 40 squared. We pick our two small sides equals the large side squared. And we get 81 and 1600, and 41 is actually 1681. So this does work because 81 plus 1600 does give me 1681. Okay? So this is a right triangle. Let's try some other ones. 8, 10, 12. So if I do 8 squared plus 10 squared plus or equals 12 squared, well, I get 64 and 100. Does that give me 144? No, it does not. So this is not a right triangle. 4, 5, 6, try it again, and we get 16 plus 25 equals 36. And unfortunately, once again, that does not work. So this does not create a right triangle. 9, 12, 15, well, you might know it as a multiple of our 3, 4, 5 triangle, but we plug it in, we say 81 plus 144. Does that give me 225? Yes, it does. So yes, this is a right triangle. So these are all Pythagorean, or 9, 12, 15 is a Pythagorean triple because it's whole numbers. But say we have things like this, 7, 11, and 170, and we say 49 plus 121, does that give me 170? Remember, I'm squaring each of these, okay? And yes, it does. So it does create a right triangle. It is not, though, a Pythagorean triple, because this is not a whole number. Same idea for this last one, and yes, it does create a right triangle. You can prove that for yourself, but it is not a Pythagorean triple. Now we can use these to solve some problems. So something like this, a ladder leaning against a building forms a right triangle with the ground. Okay, something like this with that ladder. It's 5 feet from the wall at the bottom of the ladder and hits the wall 20 feet up. How long is the ladder? And we use the Pythagorean theorem to say 5 squared plus 20 squared equals my c squared. So I get 25 plus my 400 equals c squared. So c must be the square root of 425. Now in this case, we're not going to try to put it to the nearest tenth, although we could, but let's reduce this radical. And I can split this up into the square root of 25 times the square root of 17. The square root of 25 is just 5 times root 17. And that would be how long the ladder is. Okay? And you can try this last one for yourself, same idea, but in this case, try and round it to the nearest tenth by looking at, okay, which perfect square is it closest to, and then we can start narrowing down our options. All right, well, I hope this is helpful for your homework and for studying.